build the finest data-driven businesses. Listen to real case studies, proven best practices, and learn new approaches about data engineering and analytics from companies like Cloudera, Pinterest, SurveyMonkey, Spotify, and many more. Tickets are available at crunchconf.com.
All right, thank you. So you can find more info at crunchconf.com or just come ask me. One other announcement, if anyone wants a job, you can come ask me. Yes, I work at Predictive. So without further ado, I don't think I'll introduce Szilard. I think he's probably a bigger expert on Szilard than I am. So.
And the beer.
Oh yeah, and please stick around because Szilard wants to have beer and conversation with all of you. After this, we're gonna go down to Apatsuka right next door. Okay? All right, so it's just the other tab.
Where's the click?
Yeah, so.
All right, thanks. So thanks Gergely and co-organizers of the R meetup for inviting me. And thanks Prezi for hosting, and thank you all for coming. So I gave a talk about a month ago here at Prezi. This was a data science meetup talk. So I'm trying to avoid overlapping with this talk, but just for the record, how many of you have been to this other talk? Raise your hands. So, okay, a few. So there will be a little bit of overlaps, especially in the slides, but I'm going to try to move fast over those parts. And I'd like to thank someone who I don't know, PZS, or probably from Hungary, PG, who posted the link to my machine learning benchmark that I talked about in the last meetup. So it got on Hacker News, and I got some stars there. So thank you. So quick introduction, and these are the same slides as the last time, so bear with me. I studied physics here in Budapest. I started a PhD at the physics department, but it was about modeling financial prices. I also studied economics at Central European University and was working in a bank for 5 years doing the risk modeling over there while finishing my PhD about modeling financial prices. So quite a lot of physics people now get into finance, especially here in Budapest. And about 10 years ago, I moved to California. This is Santa Monica. So I'm not sure if this works. So this is Santa Monica, the red part, and the purple is Venice Beach. Here are most of the startups in LA. And here are some other areas, downtown Los Angeles. This is Hollywood, and this is Beverly Hills. But most of the startup people like to be close to the beach, so it means that I have to pay very high rent for an apartment. So I work at a credit card processor called Epoch. So I do everything data. I'm on a small data team. I used to be alone, and now there are 2 data people. So I used to do everything, starting ETL, visualization, machine learning, you name it, everything that's called data science now. So I've been there for almost 10 years, which is kind of unusual. So at some point, purely by chance, and I will talk a little bit about this later, I started an R meetup, which was the first data meetup in Los Angeles, and I got involved into some other meetups. Some of these I'm co-organizer, some of these I'm founder, organizer, and some of these I started with a friend. So this was, if you were here at the last talk, that was the same. So now I have some new slides. So let's go back in time about how I got into R. So how I got into data. So I think the first data thing I did was about 25 years ago. This was the computer I had, and I was measuring my running times every day, and I created some little graphs. So this is the first data project I remember doing on a computer. So about 5 years later, this was the first serious data project I was doing. So this is computational physics, Monte Carlo simulations. So the tools I was using is mainly C for writing the simulations. I got my hands on a university cluster of 8 nodes. So I could run my programs in parallel. And for my master thesis, I remember running the final run for about a month on this cluster. And some other tools I've been using, Unix for, yes?
What kind of hardware are you using?
So at the Utrecht University, there was a cluster, they still are using it. It's called Szilard, and they had some Unix on it. Now they have Linux. I don't remember what Unix they had on it, and I didn't actually. This is not the true hardware, but I know it was an 8-node cluster. I have no idea what was the hardware, but I know the building where it is, but I never saw the hardware itself. So you run these computations, and then you get some data, and then you analyze. So all these Unix tools, card set, and those kind of things were useful. And then I use GNU-plot for visualizing the data. So that was 20 years ago. Not really data analysis, more like computational stuff. So the real data analysis came a little bit later, and at that time I started using more productive interactive data analysis tools like MATLAB. And then I was working in a bank, so you cannot avoid Excel. And then they were using also some specialized software for risk modeling. But basically MATLAB was my main tool. And about 10 years ago, I switched to R. And the most important thing I think to mention is that cost was not an issue. So I just joined this new company, and the very first day I made them buy a MATLAB license. At that time there were like perpetual licenses, so if you didn't upgrade, you didn't have to pay a dime after that. You could pay for like yearly upgrades. So cost was not an issue. The issue was, and I remember clearly the main reason I switched was the data frame. And a lot of people are realizing the power of data frame, right? So data frame came into Python, came into Spark recently. So what's the data frame? In MATLAB, everything was a matrix, so you could deal with numeric data. But if you are analyzing business data, then you have, I don't know, you have countries, you have clients, you have categorical data. So somehow I found R, and I found the data frame, and I switched mainly because of that. But the other reason at that time was that it had a lot of statistical packages. At that time it had 800 packages, which was way more than MATLAB or other competing tools. Now we just passed 7,000. So in 2009, so more than 5 years ago, I gave a talk at the Predictive Analytics World Conference. So this conference is where guys like SAS Enterprise Miner, SPSS Clementine, and those kind of guys are the platinum sponsor, and most of the talks about use cases with that. So companies are coming and they show how to do data mining. It was called at that time, before data science, or it was called predictive analytics, and how to do that with those kind of point and click tools. And I was in a very small minority of using coding, which I think now it's more like a majority. Most people are using R or Python in this business. But at that time, there were a few of us, and I had to argue that R was a viable tool for predictive analytics. So this is exactly a screenshot of the slides, and this too. So this was my conclusion in 2009. I had to use the name Predictive Analytics because it was a predictive analytics conference, but at that time it was called mainly data mining. Now it would be data science. So about now, I draw this to explain people what data science is. So this would be, I think, one graphic that explains the whole process, that we collect data, we explore, we use a lot of visualization, we clean the data, we transform. If you are in production, this could be called ETL. Then you're doing this modeling, and then you deploy the model, or maybe your boss asks to look some data, and then what shall we do, A or B? And then you look at the data, and it comes out that, okay, A is better than B, and you communicate that. And all this is very iterative, so if modeling is screwed up, you might need to go back to explore more data, to do more transformations or cleaning and so forth. But this is not new. So this diagram showing precisely that is from 1999. So this is called the Chris data mining process. And people from across the industry of data mining at that time, they put this together. So it's data science is not really that new. So what tools are we using for data science, or if you want data mining? So there are those on the top where you have to write code, like R and Python, open source and commercial, SAS or MATLAB. And there is also these ones that, like SPSS Clementine or SAS Enterprise Miner or Rapid Miner, that you more point and click and do all this kind of boxes. So this part I talked about at the last meetup, so I will go a little bit faster. So I tend to prefer things where you write code, because I think those tools are like more flexible, and the ecosystem around that, the libraries you get with all that, there are many more. And ultimately, the advantage of writing text is that you can put it in version control, you can keep track of changes, you can ask a question on Stack Overflow and you get help answer, or you can even send your text stuff in email. And the other thing I like is open source, and as I said, not only because it's free, but I think by now it has a much better community. There are more books, there is more answers on Stack Overflow, there are conferences, meetups. You can take a look how many R meetups are in the world, and how many people go to R meetups, and how many SAS meetups are in the world. So it's kind of like 10-to-1. And ultimately, you have the source code. So if you want to go deeper, understand what's going on, then you can just take a look. But I would say focus on quality. So if something is better and costs money, then have your company buy it. But I think in this case, the open source tools are actually better. Okay, here's my rant on tools. So I think with all this big data and data science, we focus too much on tools. So it's not only about the tools, but it's also about understanding the models, ultimately the math, doing data visualization, I think is very important, and have some kind of high-level understanding of what we want to do with all this data science part. So here are the tools I'm using. So ironically, in this talk, obviously, on our meetups, I will talk purely about the tools. I will talk mostly about R. So, but keep in mind, there are other things. So the higher it is, the more I'm using it. So I spend most of my day using R in this environment with RStudio and NeatR. I will talk a little bit about that later. Most of my data is structured, so it sits into some relational database. I'm a very big fan of Vertica, Redshift. I will talk a little bit about this later. So they are much better for interactive data analysis than the big data tools, which you can use if you really need it. And then, so Python is our friend, right? And Unix for wrapping stuff. And I was talking about H2O machine learning library last time, so if you missed it, then you can, it has been recorded, so they'll go to the data science meetups page and you will find the link. So we made a survey at the data science machine learning meetup. I wouldn't do one here because it would be biased towards R, but this could be a less biased survey. So in 3 categories: data munging, visualization, machine learning. So you can see that for data munging, most people are using R or Python. You need to get somehow the data from mostly structured data in SQL. So Hadoop, Hive, Unix shell scripts, and then a few using Excel. For visualization, also R, Python, some Tableau, and people who are building dashboards, they tend to use JavaScript nowadays. For machine learning, modeling, R, Python, and some of the rest. Well, this is a little bit biased towards open source tools, so I tend to see, and it's probably true here as well, that people working for big corporations, that they have access to very expensive, or they have policy of using expensive commercial tools. They don't tend to come to meetups. So again, back to this. So tool-wise, I think there are kind of 3 categories. The tools for data munging, the tools for visualization, and the tools for modeling. And sometimes you can do all in one. But there are also tools where you can just do some parts. For example, you can use SQL to explore the data, or to do ETL cleaning transformation, those kind of stuff. But you cannot use it for machine learning. So you can use Wabbit just for the modeling, or you can use Tableau for visualization, and maybe a little bit for exploratory data analysis. But R can do it all, right? And some of the rest is, the yellow would be more like business understanding, and the green would be more like IT or deploying stuff in production. And here, this kind of ETL, cron jobs, whatever. So what was 5 years ago? These are the slides from that talk. The one that I was saying that I was arguing that R was already a viable tool for data mining, data science in 2009. So you can see, these are screenshots of my slides. I was pretty much talking about these 3: data exploration, right, visualization, and building predictive models. So data science is not that new. So it's not like everything was invented in the last 3 years. But so we have strong foundation, but in the R world, we also added a lot of stuff since 2009. The things that contributed a lot to my workflow are Hadley Wickham's packages, RStudio, Knitar, and Shiny. So most of these products are by RStudio somehow, and they hired Hadley as well, and they hired a lot of bright people. So it's not by surprise. So, but to some extent, so you could do reproducible data analysis before Knitar and before Shiny. It was just a little bit harder. And you could emulate Shiny with some stuff. It was harder, but yeah, definitely this improved my productivity, these tools. So let's talk a little bit about our users group in Los Angeles. So I happened to start it purely by chance. I went to a conference. It was again this predictive analytics world, but another one, a previous session, and it happened to be in San Francisco, and it happened to be there I think the very first R meetup in the world. So I got a little bit inspired, and I went back to Los Angeles, and I was looking for someone, maybe started an R meetup, and I was talking to some people, and then somehow I ended up starting a meetup since nobody cared to start one. So what's the history of that meetup? Maybe it's interesting a little bit. So for about 2 years, we had like about 30, 40 people coming to the meetup. So it wasn't, right? R was not really very popular. So at the beginning, around 2009, the majority of people was, so the meetups were at UCLA, a university there. So the majority of people were students, PhD students, and faculty. A little bit later, we had more data science kind of people, analysts coming to the meetups. But even before, we kept pretty, so the topics were not very academic, were more practical. So we had someone talk from Google, or we had actually Hadley Wickham talk about this new package, ggplot2, that he authored at that time. So we had practical talks, but we had a lot of more academia-oriented people, and we were very few. So we had a room that could fit, I think, 45 or 50, and we never had waiting list. A little bit later, I started to see an influx of analysts and this kind of data science people into the meetups. The topics were kept kind of the same, so kind of practical. We did even tutorials on like creating an R package and using productivity tools. And also the attendance was pretty 30, 40 people at that time as well. Okay, at some point, the traffic got so bad that I moved the meetup from UCLA to Santa Monica to a startup. And I'm not sure what's the cause or what's the effect, but there were a lot of developers started to come to the meetups. So at that time also data science, the word became like a buzz, a hype. So we had I see a lot of developers from like traditional developer background and coming to the data field. They want to do now data science. So, and I also happened to do a panel discussion on data science. So the very first time when I created the R meetup, it wasn't that much about R as a tool. It was more about we have business problems, how do we solve them? It was more like a kind of statistical meetup, but we most of the time we talked about R and the tools. And at some point, I did this panel on data science. It was about how we analyze data. It was kind of generic. It was within the R meetup, but it was more generic. I think nobody talked about R at all. So it was about, okay, how we collect the data, how we analyze, how we visualize, what skills you need to be a data scientist. And this was like, attendance increased, and then I did another one, and I started to experiment putting just the data science name in the title of the meetup, and immediately 2 or 3 times more people came to the meetup. So at some point I thought, okay, we should start a data science meetup in its name. So I started that. And we also started a web page called Data Science NA, and that is 2014. And it also happened that the R user conference in that year was in Los Angeles, so I was co-organizer. So all this came kind of together last year. Yeah, data science is such a buzz, it's terrible. So we had one time like almost 400 RSVPs, and usually half of the people show up. So yeah, we had literally 200 people come to the meetup. And I have a friend who is doing like 4 or 5 big data meetups. So he's running the Hadoop, the HBase, the big data and the Spark meetups. And we co-organize Big Data Day LA, which is a free conference. It's on a Saturday, so it's kind of like a big meetup with like a lot of talks from morning to evening. And we have sponsors, and they give us a lot of money, so we can do it. We don't have to charge attendees, and we have great food and great talks, and a lot of people showed up this year. So a little bit about what kind of companies are in Los Angeles and who is using R. So here are 3 companies that you probably know. Who does know who is Activison? Yeah, who knows what is Call of Duty? Okay, so they are the maker of Call of Duty, and Google, Netflix doesn't need the introduction. Actually, Activison has its headquarters in Santa Monica, about 200 meters from where I work, so I know them pretty well. Google and Netflix have offices. So Google in Santa Monica, they moved to Venice, Netflix in Beverly Hills. So at Google I have a friend, and they host the R meetup every year once, and they have someone from Google talk about it. And the usual thing, you cannot record it, they don't give us slides, whatever. But still, they are very interesting talks. So they have in LA a team that analyzes of course Google is a big advertiser, right? So they hire people to test their advertising. So these are raters, and they rate, and they are analyzing the raters. So this is not big data. So they have small data, they use R. It's a small group in Google, and R works pretty well. It's mostly statistics, all kind of models, and this is what they do. They also had one of the most interesting talks. They had a guy who is responsible for the R infrastructure in Google, and he was there 2 years ago, and he said that across Google there are about 500 R users. There is an internal R help mailing list they use, and last year he told me that there are 1,000 users on the mailing list. Of course not everyone active, but I would say probably now there are like 2,000 people in Google using R to some extent. And my guess is that several hundred of them are using it very extensively. So when it comes to Netflix, they have their content group in Beverly Hills, which is close to Hollywood, obviously. So what the content group does is they deal with the movie studios in deciding which movies to buy for how much and those kind of stuff. So they do analysis and they do machine learning and those kind of things. They also use R and Python. So they gave a talk at the data science meetup about this kind of things. So I think the biggest R user in Santa Monica I know of is Activison. The data science team has like 20 people, and most of them use R. There are a few people using Python and R, and most of them are using R. So they do a lot of modeling. For example, they do a lot of game analytics. They try to find cheaters. They try to find people colluding and trying to ruin the life of other players. So this is it's a multiplayer game, and they are trying to do this kind of, it's similar to fraud detection, this kind of thing. And then there are a lot of startups. So in Santa Monica there are about, I don't know what to believe, but something like there are lists that, like they say that there are like 500 startups. So, and it's a pretty small area, it's like 100,000 people. So, years ago at the R meetup, I was asking people how many analysts, how many data scientists you have in your company, and everyone said, yeah, one, I'm the one. And about, I don't know, 3-4 years ago, I started to get answers like, oh, we have a team of 2-3 people. And now a lot of companies have teams of 3-4 people. Activison has like 20. I think Netflix is now around 4 or 5 people. And everyone wants to hire data scientists, and they are coming to the meetups and they try to hire data scientists. So last time I talked a little bit about a few things that I think can make you productive if you do data science. And I was encouraging people using high-level APIs, using tools that are fast, using environments for data analysis, like if you are in the Python world, use IPython Notebook, or in the R world, use RStudio, and use things that facilitate reproducibility. So you want to be able to do something you did today to be able to do it in like 2 months or 3 months or whenever you need to. So, and I promise that I will expand on this a little bit today, and especially related to R. So for high-level API, I think a good example is the data frame, but also most of the packages Hadley has created, most notably ggplot2 and dplyr. And I will talk about the other things as well. If you want something fast on not big data, but on like medium largish data, then I will talk a little bit about data table. For environment, for analysis, RStudio, and for reproducibility, neatar. So what is data frame? And remember, data frame was the reason I switched to R 10 years ago. So basically data frame is, you can think of like an in-memory table. So all the things you have in a database table is now in one object in memory. And you have fast operations, vectorized. And by this I mean, and you have high-level APIs for accessing this. So I used to read CSV files in C or C++ like 15 years ago, and it wasn't one line of code. So yeah, you shouldn't spend writing code to read a CSV file, right? And then here's how you create a column that's the sum of two other columns. So vectorized means two things. One is the API is nicer, so you don't need to write a loop, so such as something like this. And the other thing is the R call gets immediately to the C level. So the loop, it happens in C, right? And then it will be 100 or 1,000 times faster than if you do it in R. And so these are the two things, basically. C speed, fast, and no boilerplate, like explicit loops, like such as this one. Right, so here you would, for example, to do this, right, I want to add the y for all the x's that are greater than 0. So this is one way to do it in R. This is another way. This is really bad. It's more code, harder to maintain, harder to understand. It's, I don't know, 1,000 times slower, or maybe even more slow. And you can do it even better. So I'm a big fan of dplyr, the package by Hadley Wickham. And in this case, it's even cleaner, right? So, I mean, we like the dollar signs, but it should be about money and not about code. So I think this is cleaner, this kind of syntax or API if you want. Here, even someone who never seen R code can kind of understand what this is doing, right? Or for example, here it was this code that was adding all the y's for which x are positive, and here's the dplyr code. It's a little bit more verbose, but I think it's nicer and easier to understand. And this is one thing that you cannot do it in Python. So you cannot do this because in R you are doing this non-standard evaluation, so you are kind of intercepting this call and you are looking up, and in R you can specify this X is actually a column of D. So in Python you cannot do this. And the other thing that data frame means, so data frame means two things. One is the object with all kind of basic operations, and this was one reason I like the data frame, and the other reason is that most of our packages, they work with data frames, so they are extending the API of data frame. So basically, you see like linear model, you put the data, it needs the data in the data frame, and then you specify the model. Or visualization, ggplot, you have the data in data frame. So I think data frame is the way to work with structured data. And obviously, people other than using R have noticed this, and Python got data frames in pandas, and now Spark got data frames, right? So I think it's simply the best way to work with structured data. Actually, in Spark, you can even do more optimization by specifying this than by doing like loops and those kind of stuff. And R is great because of the other reason. There are over 7,000 packages on CRAN, and many of them are on top of this data frame thing. So, and ggplot too. So I somehow probably I should have had a slide on ggplot too, but ggplot too is so old that hopefully a lot of people are using it. So if you want something fast, R had the reputation that it's very slow. And the word comparison, like Python, 100 times slower than R for some basic aggregating and stuff like that. But a few years ago, R got this package data table by Matt Dowley. He gave a talk here in Budapest a couple of months ago, I think, or maybe a year ago. And it's just great. It's super fast. Actually, it beats Python. So it beats Python by a factor of 2 or 3. So it's not a big deal. So if you use Python, still keep using Python. So don't switch. I mean, if it was 100 times faster, then I would say, yeah. But R is not slower than Python anymore. It's not 100 times slower, 10 times slower. It's actually, if you use data table, it's a bit faster. I don't know, depends on the data size, but 2-3 times faster for aggregates and joins. So, for example, 100 million rows, a million groups, you do aggregation, this kind of group by aggregation, and it happens less than 2 seconds. Same for join. Join on 100 million rows with 1 million row in memory, and it's on one server, and it's less than 2 seconds. And I have a GitHub on this, so if you want, check it out. It's way less comprehensive than my machine learning stuff, so I don't like to publicize this too much. And it's also like it's on kind of small data. So when I ask people about data sizes on machine learning, the data sizes are smaller for supervised learning. Usually they fit on one box. If you do interactive data analysis, like simple analytics such as, let's say, aggregates and joins and those kind of stuff, the data sets tend to be bigger. So R might not be enough for data table on one single server, so you might need to use an analytical database, but maybe not big data. And when people are having like logs and those kind of data, then yeah, some people need Hadoop or Spark or those big data tools to cope with those. So it depends what you want to do and also what has been done. So sometimes people refine, like I saw a talk from the data team at Prezi, and I absolutely like it. So they have the log data, that's big data, they deal it with Hadoop and those tools, they refine it, and they put it into Redshift, which is kind of the same as Vertica or the other MPPs, right? Where you can do fast interactive data analysis, for which probably Hadoop, Hive, and even Spark is too slow. So I might make a few enemies again, but here you go. So again, this is not on big data or not even on very large data. It's on 100 million rows. It's the same as here. And this is the on log scale, the aggregation time. Here's the join time. And the surprising thing is that how bad MySQL and Postgres is for this kind of things. So about a few million rows, basically MySQL and Postgres is unable to do a decent work with aggregation in joins. So if you have like 100 million rows, you see that it takes like 100 seconds to do aggregation or more than 30 seconds. And still, this is the data is not that big. It's like a couple of gigabytes, so it easily fits in memory. And you would hope that you can get way beyond with database management systems that work on disk. So it's not at all a requirement to be in memory, and yeah, they are hopeless. And then you have this kind of tools like data table and pandas in the Python world or R deployer that are quite decent if you have like 100 million rows or less. So especially data table, if you create keys, then you get this kind of under 2 second thing. So again, the databases are pretty slow and you cannot really scale them because they work on a single server. These guys, like data table pandas, they also cannot scale on the distributed system. They are in memory on one single server. And then there is the MPPs. And this is the things like Vertica, Greenplum, Amazon Redshift. And their damn license prohibits me to publish benchmarks. So I don't want to get sued. So I just say MPP1, MPP2, MPP3. But it's those kind of guys. Actually, it's ridiculous because they are beating all the others, so they should be happy if someone publishes benchmarks. But anyway, so these guys, they also can scale to multiple nodes. So they are very fast, like you can see that under a second. And then they can go beyond the data that you can deal with R. And then the other thing are like the Hadoop and Spark and Impala and those guys. They're kind of slow, but they can scale to multiple nodes, so you can make them a little bit faster. But I think it's way more inefficient than the MPPs. So you have like a 10x, so you're gonna spend 10 times more on hardware. So as you have seen before that I use almost only open source tools. The only exception I make is the MPPs, Vertica, Redshift, and those guys, because simply they are like 10x better. So, but I tend to use open source tools for as much as I can, but unfortunately there is no good columnar database or MPP that it's open source. So hopefully there will be. So Spark R, there is a new package, Spark R, and people tell everyone to use Spark for everything. And this is a blog post by a guy, so it appeared on our bloggers, Alvaro Tejada Galindo. And okay, he had the idea to generate 1 million records and just do a grep and implement it in R and in Spark. And okay, he did the grep in Spark. It took him 26 seconds. Nice job. And he did it in R. It's 48 seconds. So, hey, Spark is faster than R. And then a few days later, somebody gave him some better code, and then the R was like 100 times faster because he was doing some crazy stuff. So I wanted to see how Spark R and R data table compares on something more relevant. So again, this aggregates on 100 million records. And this is just a gist, so you can look it up. And so I'm comparing data table versus Spark R, and I just do group by aggregate on 100 million records, again with 1 million groups. So data table can do it in 6 seconds without a key, in like less than 2 seconds with a key, and it's using 1 core. And then Spark R, after reading all the data from this, can caching it 200 seconds on 8 cores. So depends how you look at it. If you look at the best case for Spark, you use data table without keys, 6 seconds versus 200 seconds. That's a 30x. If you consider that Spark is using 8 cores, then it would be this. If you look at what R can do with a key, it's kind of this. So I think as far as you have data that fits in memory, then use something that's fast. So again, this thing. So if you do interactive data analysis, and perhaps first we go to this slide. So what if I have bigger data? And I think a lot of time when you have bigger data like logs and stuff like that, you don't necessarily need to do interactive analysis on that. It would be great, but it's simply the tools I don't think are there. So what you do all this kind of ETL and processing that's done in batch, and you put the data in Redshift or Vertica, just like Prezi does it. But a lot of people are doing different, so they are trying to struggle with other tools. So yeah, if you have any experience, then please share, like shoot me an email or something. So again, back here, it seems like of course I should have, so the reason I'm not publicizing this too much is that I simply didn't have the time to, or actually I did a little bit of experimenting with multi-nodes. I think I did with 5 nodes for the Spark and Hive and Impala and those guys, but I didn't do it for the MBDs. So it seems like if you have smaller data, like a few 10 millions or 100 millions of records, like that fits in memory, then use our data table or maybe pandas. And if you have a little bit bigger data, then use the MPBs. And if you have this kind of logs and stuff like that, petabytes of data, then probably use Hadoop for ETLing in batch. And this MySQL Postgres, there is not really well, I have most of my data for work in MySQL, but it seems like there is not a sweet spot for those guys if you want to do analytics. If you want to do all DB, yeah, sure. All right, so fast. And then I think we need an environment for doing data analysis. If we are analysts, we want to have something where we can type our code, we can run it, experiment, see the results, do the visualization, and some other stuff. And also we want reproducible research, and I'm not in academia. Reproducible research comes from academia. People want it to create products that research that is reproducible, but I think of this more like a productivity thing. So if you have to do a lot of manual copy pasting and somebody is gonna tell you to do it again, you would hate your job, and it will be also not very productive. But if you have it in IPython notebook or R-meter, you just run the whole, you make a few changes where you need to, and then you run the whole thing again. So that's what it increases, I think, your productivity a lot. All right, so feel free to contact me. Email works the best, Twitter and LinkedIn. And I'll be back in January here in Budapest. I will be teaching the data science for this program at the CU, MSc in Business Analytics. And Todd Zoli right there will teach the big data, and some other people you know will do the lab. So if you're interested, then check out the website. And this starts in September, so in 2 weeks, but I think you still can sign up. So, all right, so feel free to ask questions now or write me later an email, or we'll go for a beer. You can come with us and ask more questions, or we can also hang out here a little bit more. Yeah.
I checked your code about.
I think we have another mic, right?
Yeah.
Sure.
Or I give you this one.
It's a
Hi, my name is Imre. I checked your code in GitHub,
Yes.
and for defending PostgreSQL, it's important to set up cache memory and word memory. I don't know, you checked this?
Yeah, you mean probably for MySQL and for Postgres?
Yeah.
Yeah, I did, with MySQL I managed to tweak something and it became faster because for joins. And for Postgres, I talked in Los Angeles, there is a Postgres meetup, and I talked to someone who was very expert there, and they said that they cannot make it faster. So yeah, but so yes, you would hope. He said maybe he can optimize it, make it maybe 20% faster or something. But you saw that this was like, I don't know, 10 times faster. So it's, I mean, these products have been designed for, not for analytics. They have been designed for recording transactions, so they can do very fast inserts, updates, deletes, and they are not supposed to do like a full table scan of 100 million rows and do some aggregates or joins. So they don't work really well for this kind of stuff, it seems. But yeah, if you want to take a look, try to optimize it, and if you make it faster, let me know. Yeah.
So the license does not enable you to publish. I think you can hear me. So they don't enable you to publish the results of the MPTs. But could you please tell us now in person?
So I mean, what I can tell you is that no matter which one you pick, it's probably faster than anything else. So you can see that these three are pretty fast versus like these guys. So yeah, talk to me later. So or let's switch off the screen. No, we talk to me later. Yeah, if you really want. But yeah, you cannot go wrong with like Vertica or Redshift or those guys. So yes.
So you had that slide with the cooperation with Spark with R, and you said that the first result because
This one?
No, yes, this one. So you said that it was the bad code. Is it R so prone to bad code?
Yeah, that's a very good question. Yeah, it requires some skill, but no, this wasn't. You can check out his blog. So Google for this guy and see his blog. So I don't know what he had in mind to do. So he was just basically he was doing, instead of doing the graph, he was building the data frame, something row by row or something. So.
Okay. I've also heard from other sources that the ramp-up time to learn properly R is quite high.
Yeah, actually that's an excellent point. So I think the truth is in the middle. So I think that code was really bad. I showed this code. I showed it to a friend who is really an expert in R in Los Angeles, and he said that he probably can make this way faster, like probably another like 5x faster. So so basically for the graph, all you had to do is just do read line, and then it's vectorized, and then you can just combine read lines with grep, with the lgrep R command. And instead of that, he had like 5 lines of code with some data frames, something. So I don't know what he was doing.
And the only way to learn is to practice, do it a lot. Or do you have any other suggestion?
Yeah, I don't have any other suggestions. Spend more time, yeah. Yes.
Hi, I'm Zoli, and I saw that you are affiliated with both Python and R communities in the Los Angeles area. So what I'd like to ask you is, what do you see, is Python coming up, or is it competing with R when it comes to data analytics, or do those two tools have their different places, and what would be your take on what will change in the future? So all
it's an excellent question. I think there is a lot of posts about this all over the internet. I don't think I have more insight just for doing this meetup. So I'm mainly an R guy, so I'm kind of biased. We started the Python meetup just because there was no Python meetup, and we saw that there are a lot of people interested, and I wanted to learn more about Python, so I'm not that involved. So if you read the blog post, then you have the impression that Python is raising. I think the two part of that is that a lot of developers are coming to the data science club, and they tend to learn Python, or they already know Python, then they learn the data packages like pandas. Also, I think like 5 years ago, Python was behind R, but now they have pandas, they have Seaborn for visualization. They are like taking ideas from R, sometimes not only ideas, almost like they are implementing the stuff, so it's getting better. People are saying that people who had background in statistics, they usually use R, people who are analysts, and then people who are coming from a developer background, they are using Python. I think the main advantage people mention about Python versus R is that it's more production ready. So this guy at Google, who I was telling you about, who is managing the R infrastructure at Google, I was asking him 2 or 3 years ago, you do stuff in R, R is considered like a toy. A lot of people are asking me, do you re-implement stuff in C, C++, or Java, the stuff that you do in R? What do you do at Google? And he said, no, we just use R, we don't re-implement stuff. So if we develop some model that's going into production. So there are people using R in production. There are also people arguing that you cannot use R in production. So it's kind of a huge debate. I think I liked to look at the data. So the only data that I could collect is the survey. This one which show you that it's kind of like equal number of people using R and Python. I think we did another survey, the machine learning meetup. There Python came up a little bit ahead R for machine learning part, just because you have scikit-learn, everything is in one consistent package. In R you have multiple packages, so you can use Caret as a wrapper. And also a lot more people from computer science are doing machine learning, so so here maybe Python has a little edge. I work with structured data, so in structured data, I think if you look at overall experience, I think R is a winner. If you do a lot of text mining and stuff like that, then I might use Python more. Overall, I think it's very hard to master two at the same time, so I tend to concentrate on R and have a high-level overview of what's going on in Python, but I don't really have the hands-on experience with Python that I have with R. So if Python wins, then my career is over. All right. Any more questions? Yes.
So, what do you miss from R? And what future do you see for
Mm-hmm. Yeah, as I said, I was using R for 10 years, like like in 2009 when I gave this talk, I saw that R is a pretty good thing for an analyst. So for an analyst doing all the data mining, visualization, and machine learning stuff, if you want to do, so I think if you have structured data, then, and most people have structured data, then R is the best. ggplot has been clearly the best in visualization for exploratory stuff. I mean, if you want to create a dashboard, something like that, then JavaScript, but now Head is working on ggvis, so the web is coming to his tools, or he's coming to the web. For machine learning, as I show in the other talk, you might run out very soon of memory or CPUs. The R packages are not really great. Well, it's not R's fault. It's like they are written in C or C++, but not very optimally. And then there are other packages like XGBoost or H2O. But the good thing is that they are wrapped in R and Python packages, so you can use them in R or Python. So I would say if you do data analysis, structured, you want to do like interactive analysis or machine learning or all this, I don't really miss anything in R. So tools, even 5 years ago, tools were there, you could do it. It was a bit like the reproducible research part, and this kind of environment for data analysis part was not as polished. So Hadley and RStudio and those guys added a lot of stuff that made these tools more polished and you can work more productively. So I wouldn't say I don't know. I think if I work with text data, then probably R would need better text processing packages, but I don't.
This
Yes.
100 million rows will be sooner or later limitations.
Yes.
How this can be raised?
Yeah.
Scalability, or we are hoping in better hardware, or
Well, the limitation will be because I think memory is getting way more cheaper. So to me it seems like for a lot of companies and for a lot of data sets, actually the memory is growing faster than the data. So actually it's like an inverse big data effect. So you could see that even in the distributed computing, it had the effect that Spark is the big winner for Spark is that it's like a distributed, and it gives data in distributed memory. So then I asking people about what kind of data sets the size of data sets they're using. So it's actually smaller than you would think by reading all this big data stuff. But yeah, unfortunately, I have to give the advice that use these damn MPPs, which are not open source for now, if you run in scalability issues with interactive data analysis. If you run in scalability issues with machine learning, then use the ones I was giving a talk last time. And if you do batch processing, then probably Hadoop Spark would work. I see in Los Angeles, by the way, a lot of companies moving from Hadoop to Spark. It's a big winner because it's, 5x faster, and you have to write a higher level code in Scala than the original MapReduce API. So for ETL, yeah, definitely, if you're using Hadoop, which could scale forever, then probably moving to Spark, it's a winner, and then also can scale even better. So I think I covered the ETL, the machine learning, the interactive data analysis, and visualization. I always used to say there are like a few million pixels, so there is no big data visualization, because you always do some aggregations or something, you reduce the data and then you put it on screen. But excellent questions, yeah.
This microphone is heavy. I'm not sure how we managed to keep it for hours.
All right, any more questions? Yes?
What about your opinion, Julia programming languages?
Oh, Julia would have helped me a lot here. I think this is the sweet spot of Julia. So if you want to do some Monte Carlo simulation and you don't want to write C code, then it would have been great to have Julia here. But for data analysis, so if you're an analyst, honestly, you would spend a lot of time just doing boring aggregates and joins. So data science is not that sexy. You end up doing aggregates, joins, and stuff like that. And for that, I actually tested Julia, and it was so bad that I didn't even want to make it public. So you can run it yourself. Just do an aggregate or join in a Julia data frame. So actually, I tested, for the machine learning too, I tested a few other commercial tools, and they were so bad that I didn't want to argue with developers, and I just didn't publish it. But yeah, ask me if you want privately. Yes, other questions? Yeah.
You said you are going to teach at CU.
Yes.
Do you think it is possible to teach this stuff or learn this stuff at school at all? I know you're biased because you're doing this, but
yeah, I think still most data scientists, like 5 years ago, people who were calling themselves data scientists were coming from, they had background in like physics or biochemistry or some quantitative field, right? And I think it's probably still the case. There are a lot of startups trying to convert PhDs in something into data scientists. So I think it's still most common that you go to college, you study some quantitative field, and then you play with data, and then you become a data scientist. And the other option is to have programs that teach data science. There are, I think, a few, but actually I think most of them are like master's degrees, so they already assume that you have another degree and then you just build on top of that. So the CU program is kind of concentrated mostly, it's more like a high level thing, so it's not meant to create data scientists. It's more like a business analytics, so with a lot of focus on business. So they need a higher level. So for people who need a higher level of analytics, so they don't really need to be able to write code and do like train a neural network, but understand that and explain it to the higher level management, and also be able to work with data scientists to get good results. So, and obviously what I teach is like 20 hours. So it's, yeah, you cannot become a data scientist in 20 hours. There is a great blog post by Peter Norvig. He's the head of research at Google globally. And he has a post from, I don't know, 10, 15 years ago that's called Teach Yourself Programming in 10 Years. So he says that he hates all those books on Amazon, Teach Yourself Java or C++ in like 24 hours or 2 weeks or something like that, and that's simply impossible. So yeah, it's a huge discussion how how to become a data scientist or what kind of skills you need and those kind of things. So we've been debating that in that panel like 2-3 years ago, and we can still debate it. But essentially, I think the best route is still that you have some kind of quantitative background to some extent, and then you play with data, and you love what you're doing, and that motivates you. Other questions? All right, then we can go for a beer. Ryan is our Vasil. So, all right, thank you very much.